Simulations showed the possibilities for the redistribution of aircraft noise contained in the application of alternative approach procedures. An especially selected procedure, named Helical noise abatement procedure due to its shape, allows the concentration of approach noise in selected areas. The following video clip shows the essential elements of this new procedure developed by the German Aerospace Center. Starting with the initialization of the spiral descent, the effective noise levels on the ground are visualized until the final approach stage. Due to the enhanced complexity of this method, a combined flight test was initiated for the investigation of the interaction of all participating components. A head-to-head comparison of spiral descent and today's standard approach procedures gives an impression on the sound pressure levels together with the noise distribution for both methods. ATTAS, the principal testing aircraft of the German Aerospace Center, was used to carry out the flight tests. The approach tests were exclusively conducted with the use of a highly precise autopilot, which made it actually possible to conduct these kinds of maneuvers. Due to permanently changing wind conditions and directions, great demands were issued for the aircraft's control system. A descent rate of 1000 feet per minute during the entire maneuver was requested, while flying the helix trajectory. This could only be successfully commanded by the control of the aircraft's thrust and attitude. During flight, the approach direction was crossed multiple times, as can be seen on the ATTAS localizer display. Apart from autopilot testing, a noise measurement campaign took place, using the opportunity to investigate the calculated results in a real-life environment. Additionally, the workload for the involved air traffic controllers was closely monitored. ATTAS is arriving in the final lap of the flown helix. The direct transition to a standard ILS approach takes place. The following images show the flown trajectory and the experienced wind speeds of approximately 15 to 30 knots. The next image shows the extensive precision of the aircraft trajectory during the entire flight tests. Finally, the conducted flight tests fulfilled the expectations set. First evaluations confirm the expected effects from simulation results. Further investigations in this field are going to follow.